Having soundproofed basically all of my car, I wanted to find out, should you go to the effort of soundproofing your wheel wells, or is it just too much effort, or worse, too dangerous? Well, I decided to do it anyway, so I could tell you if it's worth doing or not, and also what you should look out for along the way. And as always folks, disclaimer, this video is for entertainment purposes only. Don't try this at home. You might be wondering what on earth gave me this idea. Well, after becoming slightly obsessed with soundproofing my cheap little car and getting decent results, I came across a walk around video of Alexas, and it explains why they are so quiet. And one thing that I noticed in that video was that the entire wheel well of Lexus vehicles tends to have full arch lining that's made of an almost felt-like material, and there seems to be patches of sound deadening in the wheel well too. So of course I want to do that, but there's a bit of a problem. If you look at the front of my car, it does have partial wheel arch lining, as do most cars, but at the back there is just nothing. So rather than fashion my own wheel arch lining, which would be a royal pain, I opted to use this material instead. And this material is a 3mm thick sound deadening mat from the UK based Dodo mat that comes as a pack of 30. So you don't need to really worry about measuring your wheel wells to calculate the material you're going to need, as 30 pieces is more than enough, and this material is their premium offering. So that means the butyl rubber in this product is meant to be much purer than the standard offering, which should make the noise reduction and vibration damping qualities better. It should also be more cost effective than stacking their standard offering on top of each other to meet the same level of thickness, and with it being a thicker material that is going on an external panel, what should you be using to apply it? For application, you are going to need a roller, but which roller should you be using? There are typically two types of rollers. One is smooth and the other is ridged. Most professionals will tell you that you should use a smooth roller, as using a ridged one tends to squash the butyl rubber down too much, essentially making it thinner, so you'll lose some of the effectiveness of the mats. However, this time around I'm going to use a ridged one, as the area I'm applying these mats to is in quite an exposed position, so you definitely want to make sure that they are stuck down to the surface properly so zero moisture can get in, as if it does, you'll likely create the perfect opportunity for accelerating the creation of rust, which we very much want to avoid. In most cases, you'll also want to make sure you are applying these mats to a clean surface, but this time around, this can't be stressed enough. The wheel wells need to be so clean, you could literally eat off of them, because we not only need to worry about moisture getting in once they are applied, but we also need to make sure all the dirt and moisture has been eliminated from the surface before a mat is even applied to it. And to do this, it does sound quite labour intensive, but a pressure washer makes quite light work of all the dirt and grime under there. And don't worry if you don't have one, you can hopefully find one at your local petrol station, but it will be much easier doing it at home, as you can take the wheel off and get under there properly. Once the wheel wells have had a good blasting, I went in with a sponge and some soapy hot water to make sure all of the grime from all the little tight, hard to read spaces was eliminated, and then made sure to dry the entire wheel well afterwards with a microfiber cloth. After that, I used some prep spray, more commonly known as degreaser, in order to get rid of any grime or oil on the surface, and you really do want to make sure that you're happy with how clean your surface is before you apply any of your mats. Once you're good to go, the mats can be applied, and in the past I've always advised for complete continuous coverage of surfaces, which basically means making as fewer cuts to the mats as possible, only because it weakens the structure and stops them working as effectively as they could. But when you are working on a surface like this, you really have little choice but to apply your materials as best you can and overlap them where needed. You may even end up in a situation where some of your mats tear as a result of the pressure applied to them, but don't worry, you can just cover them with some more sound deadening, making sure it's properly adhered, and when you've completed the entire wheel well, you should have something that looks like this. And it's worth taking your time to poke and prod around to make sure the mats are properly stuck on and that you're happy with the final finish. And then you can repeat this on the other front wheel well, and with this being the front, it took about 2 hours, so it makes sense that it would take about 4 hours to do both sides. And feeling full of success, I decided to move on to the rear wheel wells, and I was not prepared for the trouble they were going to give me. After spending ages cleaning them, which took longer than the front wheel wells because of how exposed they are, and I was genuinely proud of how clean I'd gotten them, only to find out that when I went to stick my sound deadening mats onto the surface, they just would not stick. And I aren't sure if it's because there is some kind of coating applied to the rear wheel wells, or if it's just the texture that makes sticking anything down next to impossible, but my mats just would not stick. But with a a bit of head scratching, I had a solution. I'd heard about Boom Mat before, which is one of the many brands of spray-on sound deadening that will basically stick to anything. So my idea was to put this stuff down as a base and then put the mats on top of it. But that was just a theory that I now needed to put into practice. I started by spraying small amounts on the rear wheel wells after giving the can a good shake, and this stuff goes on rather easily, although it unnervingly bubbles up as you apply it, but it quickly flattens out, and with it being a spray-on product, you do have to be careful where it goes because it can go everywhere. I managed to get some on the outside of the car, but it did wipe off with these abrasive wipes that are really quite good at getting the stuff off your hands too. And of course, you want to wear a mask when spraying this stuff. Once you've applied it to most of the surface, the can suggests that it takes about 20 minutes to dry to the touch and 6 hours until you can paint it. That's right, you can paint it, which is a good way to apply product to your car without people knowing if you wanted to do that. But after touching it after 20 minutes, it was still not dry, and it was still drying when I came back an hour later. So I left it overnight and then worked on it the following day. So that's worth keeping in mind if you do use this stuff or need to use it like I did. It will take several days to complete this little project if you need to add this step. It also drips too, so don't be thinking you can invert the can and it will adhere like spray paint, because it won't. But once it's on and dry, we need to test if it actually allows me to stick anything to it, and lo and behold, it does, which I was very relieved about. I started by sticking one huge piece which adhered with little effort, and then obviously went in with a roller to make sure it was stuck on there properly, and after a bit of prodding and poking, I then went on to complete the whole wheel well, which took about an hour. So I'd say about 2 hours of labour would be about right for the rear wheel wells, so you need about 4 hours to do both, putting the total time about 8 hours of actual labour to do all 4 wheel wells. But we need to discuss if it's actually worth doing. So let's do a bit of a deep dive and get into the results, shall we? When looking at the results, we're going to cover a lot of ground here, starting with how these results were captured, what the results sound like by just listening to them without decibel readings, what decibel improvements we can see with a decibel meter, what improvements we can see to frequency by looking at spectrogram samples, what perceived daily improvements you'll likely notice, how much doing something like this will cost, what are the negatives of doing something like this, and what improvements can be done to make it even better. Starting with how these results were captured, I recorded everything on my phone with an external mic that does not automatically adjust the gain. If you're not familiar with automatic gain, it's basically the default on most phones that adjusts mic sensitivity so that you get consistent audio levels. My mic does not do this, so what you're hearing is unfiltered. When I recorded these results, I always travel on the same roads to make the comparisons as fair as possible. I also try and do them on the same day where possible to try and mitigate the difference in circumstances, as one day might be windier than the next, and I never record in the rain as it just makes results too hard to compare. And with that said, before looking at decibel meter results, just have a listen first to see how much of a difference you can perceive in these next set of clips. Listening to the clips at 30 and 50, it sounds like they have a lower frequency drone in the after clips, meaning there is potentially less tyre noise getting through, but this is less so at 70, which shouldn't be too surprising as it's harder to block noise at higher speeds. But does this change come through when you use a decibel meter? Looking at the results in detail, you can see at 30 we have a drop of 2.3 decibels, at 50 a drop of 1.4 decibels, and at 70 a drop of 1 decibel, which is quite a nice drop across the board to say all we really did was to try and reduce tyre and road noise with one layer of sound deadening. And you might have a few questions straight away, like how did you even get these averages? Well, in each 5-second-ish clip I noted down each time the decibel meter changed as best I could, and then calculated an average logarithmically, and because the human ear essentially perceives sound intensity in a non-linear way. You can't just add a bunch of numbers together and then divide the total. You have to do it with a logarithmic formula, which I did in Excel, and that's the simple answer as to how I got these results. Secondly, you might be wondering what these drops mean in terms of how you're going to hear them, or in plain English, will you notice a difference? Well, what those drops in decibels sound like as perceived loudness, which is basically how the human ear perceives sound pressure, which again, you need to calculate logarithmically, translates at 30 mile an hour to about a 15% reduction, and that drops off the higher you go up in speed, so about 9% at 50 mile an hour and then 7% at 70 mile an hour. And how you will hear this depends on the person. People who have sensitive hearing will notice it more than those who don't, and in general it takes about a 3 decibel drop to notice any audible difference, but decibels aren't everything. Frequency also plays a huge factor and might explain why your ears notice a big difference even though decibels haven't changed all that much. And to examine this, we are going to look at some before and after spectrogram samples to see if we can see any improvements. If we dive into Audacity and look at the spectrogram version of our clips, which essentially shows us what is going on at a frequency level, you really do get to see the benefits up close and personal. And because tire noise tends to occupy a lower frequency band ranging from 200 Hz to 2 kHz, it makes it easy for us to focus on this bottom section here. And looking at the results at 30 mile an hour, you can see that that bright, intense yellow banding at the very bottom is much less intense in the after sample when compared to the before sample. And you'll also notice that the red band above is slightly thinner too, meaning that overall frequency intensity is lower than before. But is it the same at 50 mile an hour? Looking at the before and after, we can see that the very intense bright banding at the bottom hasn't changed very much, but it does look like the red intense banding between 0 to 1 kHz looks thinner and more evenly spaced than it did before we added the sound deadening, which is nice but not as impactful as it was at 30 mile an hour. And this trend continues when you bump the speed up to 70 mile an hour, which makes sense as it's harder to control the lower frequencies the faster you go. But you do see a smoothing out of the general intensity, meaning in real terms that it's going to be less fatiguing on the ear, which is nice. And overall, we see a trend of that deep road rumble at lower frequencies being reduced and that tire noise not being as prevalent as it was. And before we chat through the real world benefits of what it's like driving around with these improvements, if you are getting value from this video, please do drop a like below so you can help this video spread. And if you're feeling extra nice, please consider donating via Buy Me a Coffee, which really does help not only keep me caffeinated, but it keeps the channel alive and it allows me to buy materials and tools to test and use. YouTube money only goes so far, and the real value is you, as it's people like you who keep the channel alive by watching and donating. So if you do want to donate, the link is below. Thank you very much. Jumping back into the benefits and what you'll likely experience on a day-to-day basis, I'm actually really excited to talk about this bit as I've been keeping it under my hat until now. As a brief summary, we know that perceived loudness is going to be reduced from between 15 to 7%, and you are seeing a drop in those intense frequencies basically across the board. So driving around is going to be less tiring on the ear in general, and you should feel more comfortable driving around town and even a little better at motorway speeds. But the real benefit is how it feels, and I was genuinely shocked when I drove my car after I'd fitted these soundproofing mats, as it felt like I was driving on ice, as basically all the micro vibrations from the tires seemed to have disappeared, and it was very weird. It was so weird, I had to make sure that I'd put the wheels back on properly. And even now, when I get in the car, I cannot believe what a difference it makes having these mats on. And I think it's in large part to do with the quality of the material. And there's a few reasons why I can say that with some confidence. For those who have been watching for some time, you'll actually know that this isn't the first time I've tried this. About 2 years ago, I made this video where I applied some 50mm kill mat material onto one wheel well to see if it made a difference. And while I noticed the difference in sound at 30 mile an hour, the actual feeling was largely the same as if I hadn't applied anything at all. So this thicker, more premium material clearly makes the difference. And for those who are wondering, this isn't sponsored. I spent my own money on this stuff, and you can really feel that the proper butyl in these mats does a much better job of soaking up those vibrations, which is essentially what sound deadening mats are meant to do. So the fact that we are also getting lower decibel readings as well is real icing on the cake. And the second reason why I know that these materials are making the difference is because I've soundproofed most of my car with regular 50 to 80mm mats, and they don't feel anything like this. So in my view, these mats are are a real step up, and they continue to offer benefits outside of the much more comfortable ride. Because as any car owner will tell you of late, potholes and general road conditions, at least here in the UK, are becoming worse and worse. So in my view, there hasn't been a better time to really do something like this, and it really does help deaden those thuds and bumps on the road, so you aren't as impacted by those large potholes when you go over them. But of course, it doesn't mean you're suddenly driving a monster truck. It's just that you won't feel the bumps as much as you did, and if these materials are applied correctly, you're protecting your vehicle from all the stones that get flung up there, as well as protection from the elements, and we will talk about that in a bit more detail shortly. But with these being premium mats, what does all this cost? Well, for one box of 3mm Dodo Mat Pro sound deadening mats that contains 30 mats, you'll be paying £90. But you have to keep in mind that you likely won't need all of those, so the spare mats that you haven't used can be used for other parts of the car too, which I will be doing in future videos. But to cost it more accurately, I used 3 mats per front wheel well, so that's 6 in total, and then 4 mats per rear wheel well, so that's 8 for the rear. So combined, I've used 14 mats, which is about half of the box. So you'd be looking at a material cost of about £45, which is expensive, but very much worth it in my view, given that most people will only be doing something like this once, and the jump between entry-level mats and these is really quite stark, so you might as well go for the best if you can afford it. And for those of you not in the UK, our American viewers may very well be familiar with Resonix that offer highly rated premium options, and if you're in Europe, it might be worth trying to get hold of either of the ones I've mentioned, as I'm really not sure what brands are reputable in Europe. So if you do know, please drop a comment below with your recommendations. Jumping back to cost, if you remember, I had to buy some Boom Mat spray-on sound deadening that cost £23.50, so you are looking at a total spend of £113.50, or in actual used material cost it would be £68.50, because we've only used half of the box of sound deadening mats, so it isn't too bad when you look at the actual cost. And I haven't costed things like prep spray or rollers, as these may be things you already own, and I've costed them in other videos, so this just covers material cost. And this brings us on to what the negatives are of doing something like this, because surely it can't be all upside, can it? Well, those of you that are savvy soundproofers might already have at least 3 questions in your head. First one being, why have you put these mats on the outside when they are clearly meant for interior use? And you know what? You're absolutely right. These are not designed to go on exterior wheel wells. So why on earth have I put them there? For me, access to the interior of the front wheel wells is basically impossible due to how compact and oddly shaped my particular car is. So using something like this on an external panel is more of a necessity than anything else, at least for the front. The issue isn't really prevalent on the rear, but as I am doing the front, I might as well do the back to show you folks what it's like. The obvious next question would be, are these mats waterproof? And the answer is no, they aren't. They are water and oil resistant, but here is why I aren't worried about that. If you remember, I've done this on one wheel arch previously about 2 years ago, and after a year of trialling the mats on the exterior wheel well, having taken an absolute beating from all manner of rain and dirt, I took them off to see if there had been any signs of rust, and when I got them all off, the panel looked basically like it did before I soundproofed it. No signs of rust at all, so personally I'm not worried about that. However, if I were to do it again, I would change a few things, and here's why. Firstly, I'd opt to use Boom Mat or a similar spray-on or paint-on product on the exterior wheel wells exclusively, rather than the mats that I used, and that's for a few reasons. Soundproofing mats really should be on an interior surface rather than an exterior one, and while I aren't too concerned about rust, Boom Mat seals out moisture for that extra peace of mind, and it can be painted, so you could get more of a stock appearance and even invisible if you paint it. No one would ever know. Secondly, using something like Boom Mat on the outside is much easier to work with on an exterior panel like this. As I mentioned earlier, in regards to how much time this took, it took about 8 hours plus to clean and install everything, and if I'd have used Boom Mat or an equivalent product instead of using sound deadening mats, I believe that installation time would have halved. So I could have done it in 4 hours instead of 8 and had a much easier time of it too. Lastly, I tested having only Boom Mat on the rear wheel wells, and you could actually feel the difference when comparing it to stock. So you could technically apply multiple layers of this and get somewhere close to the mats that are on there, and this can only cost £23.50, and you'd likely be able to get 2 or 3 coats of each wheel well. So as an easier and potentially equally impactful result, that's the way I'd go. But there are 2 more questions left in your mind that I've yet to answer. Why didn't you just soundproof the wheel arch lining and then take the entire interior out and soundproof under there? Well, that's because I've already done that and these two videos are there, so see you there.